differential equation of first order and first degree. If we replace dy by dx by p, that is, if we take p is equal to dy by dx, then this differential equation can be written as p power n plus p1 p power n minus 1 plus p2 p power n minus 2 plus and so on p n minus 1 into p plus p n y is equal to 0. Okay, this equation is also simply we can write this form where p1 comma p2 comma dash dash here pn minus 1 pn minus 1 comma pn are functions of x1 are functions of x and y. Now for this differential equation we can write in a simplest form. It is a function of x, y and dy by dx, and we are taking dy by dx as p, so it is the function of x, y and p where p is equal to dy by dx. This is the differential equation of first order but not first degree. Okay, now these equations can be divided. These equations can be divided into four types. First one is, number one is equations solvable for y. Equations solvable for p. Second one, equations solvable for y, and the third one is equations solvable for x. Equations solvable for x, and the fourth one is Clairaut's equation. Fourth one is Clairaut's equation. Okay, the differential equation of first order and first degree are divided into four types. First one is equations solvable for p, and equations. Second one is equations solvable for y. Third one is equations solvable for x, and fourth one is important one is Clairaut's equation. Okay. Now, questions first equation solvable for p, and fourth one Clairaut's equation. The two bits నుండి మనకు క్వశ్చన్స్ ఎక్కువ అడుగుతున్నాడు. ప్రీవియస్ క్వశ్చన్ పేపర్స్ కానీ సెట్ పేపర్స్ కానీ చూసినట్లయితే ఇక్కడ నుండే ఎక్కువ క్వశ్చన్స్ అడుగుతుంది. ఓకే, ఫస్ట్ ఐ యామ్ టేకింగ్ ఫస్ట్ వన్, దట్ ఈస్ first one, equations solvable for p. Okay. First, the given differential equation in the form of f of x comma y comma p is equal to 0, where the notation p is equal to dy by dx. This is the first order derivative, and this equation can be factorized into linear factors. That is, we can write it as p minus f1 of x comma y is equal to into p minus f2 of x comma y into p minus f3 of x comma y into and so on. Last term is p minus fn of x comma y is equal to 0. First, we have to factorize the given differential equation. After factorization, we have to solve this equation. Okay, and the solution is in the form of the solution of first factor. Factor is we are taking pi of x comma y comma c1 is equal to 0. Second factor's solution is it is pi 1 of x comma y comma c1 is equal to 0. Second one is pi 2 of x comma y comma c2 is equal to 0. And the third one and so on. The nth factor solution is pi n of x comma y comma c n is equal to 0. After getting the solutions, we have to replace c1, c2 and so on cn by c, replacing c1 by c, c2 by c, c3 by c up to and so on cn by c. Therefore, the required solution is of the form the solution is of the form pi of x comma y comma c into we have to multiply. This is the first function pi 1 of x comma y comma c, and the second function pi 2 of x comma y comma c into and so on. Last function pi n of x comma y comma c is equal to 0. This is the general solution of the given equation which is solvable for P. First we have to factorize, then solve the each factor and replace C1, C2 and so on Cn by C, and we have to take the solution which is in the product of all solutions that is equal to 0 gives the general solution of the equation which is solvable for P. For example, I am taking one problem here. The solution of p square minus 7p plus 12 is equal to 0, where p is equal to dy by dx. Clearly, it is an equation which is solvable for p. So we have to factorize this. That means we can write it as p square minus 4p minus 3p plus 12 equal to 0. P as common, p minus 4 minus 3 as common, p minus 4 is equal to 0. So p minus 4 into p minus 3 is equal to 0. Now equating each factor to 0. It is p minus 4 is equal to 0. Second one is p minus 3 is equal to 0. So here p is equal to 4. P is nothing but dy by dx. Dy by dx is equal to 4. When dy by dx is equal to 4, we can write dy is equal to 4 into dx. Now by integration, we get to y is equal to 4x plus c1. So here y minus 4x minus c1 is equal to 0 is the first solution. And solve this equation. P minus 3 is equal to 0. That is p equal to 3. That is dy by dx is equal to 3. Dy is equal to 3 into dx. Now integrate on both sides. We get to y is equal to 3x plus arbitrary constant to c2. So y minus 3x minus c2 is equal to 0. This is the second curve. Therefore, the required solution is we have to replace c1 and c2 by c, and we have to take the product. That is y minus 4x minus c into y minus 3x minus c is equal to 0. This is the required solution of the given differential equation. Okay. Now take another example. The solution of the solution of x square p square plus xyp minus 6y square is equal to 0, where p is equal to dy by dx. This is the now this equation can be written as x square p square plus, to take the factorization here, 3xyp minus 2xyp minus 6y square is equal to 0. So take xp common here. Here remaining xp plus here 3y minus 2y common here, xp plus taking minus common 3y is equal to 0. Here again xp plus 3y common. So xp minus 2y is equal to 0. Now we have two equations here. That is first equation xp plus 3y is equal to 0. So this can be written as x into p is equal to minus 3y, x into dy by dx is equal to minus 3y. So we can write it as dy by y is equal to minus 3xy. This is the dx, 3 by minus 3 by x into dx. So by integration we get log y is equal to minus 3 log x plus arbitrary constant log c. So here log y is equal to log x power minus 3 plus log c1. So y is equal to c1 x power minus 1 minus 3, nothing but c1 by x cube. That implies x cube y is equal to c1. So x cube y minus c1 is equal to 0 is the first. After solving first equation, now solve the second equation. So the second equation is xp minus 2y is equal to 0. So x into p means dy by dx is equal to 2y. So we can write it as dy by y is equal to 2 by x into dx. Now integrate on both sides. We get log y is equal to 2 log x plus arbitrary constant log c2. So y is equal to c2 x square. That is y minus c2 x square is equal to 0. This is the second one. So the general solution is or the complete solution is first curve, that is x3 y minus c, and the second curve y minus c x square is equal to 0. Just replacing c1 by c and c2 by c. So we get the solution of this one. Okay. Now we can do some problems after discussing solvable for y, solvable for x, and previous equation. Okay. Now I am taking equations in which equations solvable for y. Second one is equations solvable for y. So the given equation in the form of f of x comma y comma p is equal to 0, where p is equal to first order derivative dy by dx. So if it is easy to write, y is equal to f1 of x comma p. F1 of x comma p. Now take this as equation number 1, and this is equation number 2. Now differentiate equation 2 with respect to x. With respect to x, and replace p by dy by dx. Then the differential equation dy by dx, we are differentiating with respect to x. That is nothing but p, that is equal to function of x comma p comma dy by dx. Now separate the x dx terms one side and p dp terms on it. This is nothing but f of x comma p comma dy by dx. This is also p. Now we can solve by separating the variables. Okay, we get the solution. We can eliminate p from these two equations. After eliminating p and substitute in the equation 1, we get the required solution. Okay, I am taking one problem here. The solution of y plus px is equal to x power 4 p square, where p is equal to dy by dx. So it is difficult to write the x value. So it is easy to write the y value. So we can write y is equal to minus px plus x power 4 into p square. This is equation 1 and this is equation 2. Now differentiate equation 2 with respect to x. Differentiate equation 2 with respect to x. We get. Now y differentiation is dy by dx is equal to minus, here it is UV method, p into x derivative is 1 plus x into p derivative is dp by dx. Again here UV method, x power 4 is constant, p square differentiation is 2p into dp by dx, plus p square is constant, x power 4 differentiation is 4x cube. Okay. Now we can take dy by dx value as p, that is equal to minus p minus x into dp by dx plus 2p into x power 4 into dp by dx plus 4x cube into p square. This is the p value. Okay. Now to solve this equation for p, okay, after simplification, we can write this equation as minus 2x by, I'm writing directly, it's only simplification, minus 2, sorry. This equation can be written as dp by p is equal to minus 2 by x into dx. Now integrate on both sides. So we get to log p is equal to minus 2 log x plus arbitrary constant is log c. So p is equal to c by x square. So p is equal to c by x square value, equation number 1 lo substitute cheyandi. Therefore from equation 1 we have y plus p is equal to c by x square into x is equal to x power 4
సార్ ఇక్కడ
C
డైరెక్ట్
square
స్టెప్
by-
ఎట్లా తీసుకున్నాం సార్
sir
ఇంటిగ్రేషన్ ఆఫ్ dp by dx dp by p ఈక్వల్ టు
దీన్ని సింప్లిఫై చేయండి సార్, దీన్ని జస్ట్ సింప్లిఫై చేయండి, ఓకేనా.
ఓకే ఓకే ఓకే
కొంచెం లెంతీ అవుతుందని నేను స్కిప్ చేశాను, డైరెక్ట్ రాసేసి. ఓకే, యూ హ్యావ్ టు సింప్లిఫై ద ఈక్వేషన్. దిస్ ఈస్ c square by x power 4. Here x power 4 will be cancelled, here 1x is cancelled. So the equation of the form y plus c by x is equal to c square. Or we can write this equation as xy plus c is equal to c square x. Okay, this is the general solution of the given differential equation. Okay, ఎక్కువ మనకు solvable for y and solvable for x నుండి క్వశ్చన్స్ ఎక్కువ రావట్లేవు అండి. That's why I'm taking only one example. Okay, taking the next one is equations solvable for x, equation solvable for x. Now the given differential equation in the form of f of x comma y comma p is equal to 0, where p is equal to dy by dx. Okay, it is easy to write x value. That is, if we write x is equal to f1 of function of f1 means function of y comma p. Now let it be equation 1 and this is equation 2. Now differentiate this equation with respect to y. Differentiate this equation with respect to y. So we get dx by dy value, that is dx by dy is equal to some function of y comma p comma dp by d. Okay, here we know that p is equal to dy by dx, then dx by dy is equal to 1 by p. Now solve this equation. 1 by p is equal to function of y comma p comma dp by dy by separation of variables, yp terms one side and dy terms y dy terms one side, pdp terms are on either side. After eliminating p, we'll give the required solution. It is not easy to eliminate p from the equations, so we write the general solution as the product of equation 1 and the product of integrable equation. Okay, now I'm taking next topic is, okay, we'll take one example here. The solution of y square log y is equal to xyp plus p square, where p is equal to dy by dx. Okay. So it is not easy to write the y value, so I am writing x value. So xyp is equal to, first I am writing, that is y square log y minus p square, and we can write x is equal to y log y by p minus p square by yp, nothing but p by 1. Okay, let it be equation number 2. This is equation 1 and this is equation 2. Now differentiate equation 2. Differentiate equation 2 with respect to y. While writing x value, we have to differentiate with respect to y. While writing y value, we have to differentiate with respect to x. So we get u by v formula. You can differentiate this by u by v. It is also u by v. Now, after simplification, I'm writing directly dp by p is equal to dy by y. Here we are separated p dp terms and y dy terms separate. So we get log p is equal to log y plus arbitrary constant c. That is p is equal to cy. So p is equal to cy. Substitute this value in equation number 1. Therefore, from equation 1, we have y square log y is equal to xy into p cy p square, that is c square y square. So we can take y square log y is equal to y square as common. So cx plus c square and y square will be cancelled. Log y is equal to cx plus c square is the solution. Okay, you have to remember it is a problem. It is easy to write y value. We have to differentiate with respect to x and eliminate and separate x dx terms one side and the y dy p dp terms another side. Similarly, if it is easy to write, x value, then differentiate given equation with respect to y and separate y dy terms one side and p dp terms another side. Eliminate p value and substitute in equation 1, we get the required solution. Okay, it is not eliminated. It is not easy to eliminate p value. So the solution becomes the product of first equation and the integrable equation. The integration is a equation, first equation product general solution. Okay, no need to worry about solvable for y and solvable for x. And to concentrate and solvable for p and on clearance equations. Okay, now we go for clearance equation. It is important clearance equation.